We're going to go ahead and share again. And this time, we're going to talk about testing a mean. So we're going to go back into here. We're going to go into 7.3 notes. And this one, we're going to test just a mean. It's called a one sample test. We're not going to do a whole bunch of calculations on this because really people don't just test one mean to a known value, which is what this is about. So even though we have it in the books and we talk about it, this really isn't something we actually do. But I want to kind of introduce it with the idea because there's some concepts we need for this to talk about what we're going to do in the future. Okay. So this is known as a one sample test. And the reason it's called a one sample test is because I collect just one sample. I want to compare the housing prices to the housing prices in Phoenix where I know what the housing prices in Phoenix are. I want to compare the GPA of students in my class with some known GPA of students in the university. I want to compare the time it takes, well, the incubation period for the coronavirus and compare that with the incubation period for other viruses that are known out there. So again, we don't normally do this where we're comparing to some known value because we don't necessarily have that known value all the time. We're going to be looking later at what we call two sample tests, where we actually compare one sample's values to a totally other sample's values. So where I might compare the corona incubation time to the flu incubation time. Or I might compare the GPA of students in my class compared to the GPA of students in biology classes. Or I might compare the housing prices in Flagstaff to the housing prices in Phoenix and collect samples from both groups. Those are called two sample tests. We're going to be doing those next week. Right now, we're talking about this one sample test, but there's some concepts we need from this. Does that make sense? Are we all okay with that right now?
Yeah.
Okay, there's no homework on this section. There originally was, but I've removed that homework. So when you see section 7.3, don't worry about doing any homework on that. I did actually decide you don't need to be doing this because it's just more hypothesis tests. I'm going to get more into that next time.
Okay.
All right, plus, if you really want to know something about a one sample mean, you would just do a confidence interval, which we'll talk about that next time. So what it is that going back to what we did last time when we talked about this mean, we're like looking at the mean. What were we looking at? We were looking at the mean, of the mean.
Normally distributed thing.
Yeah, the mean poverty level, poverty income level for people who own versus people who rent. So we were looking at that. If I just did it for just people who own and compared it to some known value, I would actually do something called a z-test, where I actually could calculate this z value, find the z-score for it, and then compare it to 2 and -2. And that would be called a z-test because it uses a z value. In order to do this z-test, I need to know the mean, which I'm going to assume what it is, and I need to know the population standard deviation. So the question comes up, what if I don't know the population standard deviation? What do I do in that case? So if I don't know the population standard deviation, I could just use the sample standard deviation. That makes sense. Why not use them both? So back in the early 1900s, people started asking the question, can I do that? Can I just use the sample standard deviation and replace it in there? Is it still a normal distribution? And the answer is no, it's not. And so they started looking to see what it was and how to figure it out. And a man by the name of W.S. Gossett actually figured out what the distribution was, and he called it the student's T distribution. So I want to first off mention it's not called the student's T distribution because only students use it. Gossett at the time worked for a company that I'm sure you've never ever heard of. It was a company in Ireland called Guinness. Never heard of that one, right?
No, I never heard of them.
Never heard of that one. I drink Guinness all the time, but that's beside the point. I'm sure some of you also drink Guinness. And it really was Guinness, the brewery, Guinness. He worked for Guinness. He was a chemist that was hired by Guinness to, so I don't know if you know this, but when you make beer, Does anybody know how to make beer?
Yeah, don't ask me step by step because I'll probably stumble a bit.
No, I don't want it step by step. I'm just curious with your beer, what is one of the main ingredients you need for beer?
Yeast
Yeast?
Sugar.
What else? Sugar?
or something with the starch in it. Yeah,
What else?
wheat.
In
Or
the men's
grain.
room, man.
Grains of some kind? And there's a major one you guys are missing.
You can have my what?
Time.
Time.
Huh?
Is it
Time.
You
hops?
can have my what?
Hops? No, there's a bigger one than that everybody should be able to get, even if you don't know how to make beer.
Water.
Water.
Hmm?
Mm.
Everybody uses water. Well, what do we know about the
You
Flagstaff
MacGyver.
water as opposed to the Phoenix water?
Oh, it's
Way
different.
better.
It's from a different source.
Flagstaff water is way better than Phoenix water. Phoenix water sucks.
Yeah.
If you make beer with Phoenix water, it will not taste the same as Flagstaff beer wouldn't taste like. All right, it would not in the least bit taste exactly the same. And companies know this. So I actually went to North Carolina a couple summers ago and went to a bunch of brew pubs and microbreweries. And one of the places I actually went to was Sierra Nevada. They actually
That's
have
gonna get on,
a
so let's run it.
brewery in North Carolina along with their brewery in California. And they make beer in North Carolina just like they make beer in California. And they make sure that their water in North Carolina is chemically the same as their water in California.
Oh,
Okay. And they actually show you that on the tour. So if you do the tour, they'll show you where they actually process the water and try to make it be the exact same chemically as the water over here. Well, this is what Gossett was doing for Guinness. He was actually trying, because Guinness was huge, and Guinness is still huge, and they do make
Still in
beer
my
other
Zoom
places.
class, Lamau. I forgot about it.
So
I
they
just had the
wanted,
volume turned down.
who's talking? Yeah, if you can just mute yourself while you're talking to somebody else, that's fine. So what they did
I'm
was
still
they
in my
actually
Zoom
created,
class, lol.
Really?
Didn't realize.
who's talking? Somebody's talking. Can't tell who.
They're talk to texting.
Did he?
All right. So what happened was Gossett was actually hired by Guinness to try to make sure the water was the same in different places. Guinness didn't want anybody else to know they hired a chemist. So he was not allowed to publish anything he did under his own name. And companies do this all the time. They tell you either they own what you publish or you can't publish it under your own name. And this
All right,
happens all
let's
the
play one
time.
without him.
All right,
I think
so
we-
Question is, am I leaving?
whoever is talking, if you have a question, ask it. Otherwise, mute yourself, please, or I'm going to mute everybody. I can do that, by the way. I had that power. All right, so what they did was he worked for them, and he came up with this research he was doing to try to answer this question of how to make the water the same. And he had to come up with this new distribution. And he called students so he could actually publish it out under his own name. So that's the only thing it's called student is because he's a student of the world. Has nothing to do with anything else. There are some assumptions for this student's tea distribution. We're going to talk about them when we get to a little bit. But this is what is known as the student's tea distribution. And then this is what it looks like. This is the formula for it. So if you want to do calculations, you can do them with this formula. It's not too hard of a formula, except if you have a really big sample. Finding X bar and S, you would want to use R anyway. So if you're going to use R for that, you might as well use R for the rest of it. There's this thing called a degrees of freedom. So I want to show you what the graph looks like. This is actually what the graph looks like. This major high curve, that's your standard normal curve. This curve here has a degrees of freedom of, let's say, 2, and this lower curve has a degrees of freedom of 1. If I were to draw in some more, and I think I thought there was a way to draw these, right? A way to draw, insert a drawing? Maybe not. I don't want to do that. But there is a way you can actually draw these, and each time you draw one with degrees of freedom, it changes. So what I want to do is talk a little bit about degrees of freedom. And so I usually do this in class where I have people come up with their chairs, but we don't have chairs and we can't do that. but we're going to kind of look to see what's kind of happening here. And let's say we have 5 students with 5 chairs. The first person gets to choose from how many different chairs to sit in?
5.
5. That person then sits in a chair. So the next person has how many choices to pick from now?
4.
4, because there's one less chair. That person sits down. The next person has how many chairs to pick from?
3.
3 and then
3.
so on.
And so forth. So the last person has how many choices?
1.
Really? Do they actually get to choose?
None.
No.
None. They actually have no freedom of choice. So even there were 5 people, only 4 of them had freedoms of choice. The last one gets no choice. So you can kind of think of degrees of freedom as that idea, is that you lose one choice of freedom from how many you started with. So if you start with n data values, you actually have, let's say you start with 1,000 data values, you actually only have 999 freedoms of choice, because the last value actually gets no choice in it. So even if we start with 1,000 people taking chairs, only 999 of them would get choice. And that's really a good understanding of what degrees of freedom is and how it works. Notice that your degrees of freedom increases, you actually get closer and closer to the standard normal curve. So he found out it was really close to the standard normal curve, but it wasn't actually the standard normal curve. But it gets closer as n gets bigger and bigger. All right, so we
Sounds like a
actually now,
calculus
go
problem.
ahead.
Sounds like a calculus problem.
It is kind of a calculus problem, though actually yeah, it's kind of like a calculus problem,
It's like
but
it's approaching
we
infinity.
don't actually do this in calculus. We don't actually do any problems with this. All right, and we're gonna do something called a t-test for the mean. This is called a t-test because we're using the student's t. Why did he use the student's t? Probably because he wanted to use z and couldn't use z, so he used a t. I don't know, but that's just the name we have these days. So we're gonna do a t-test for the mean that we're gonna be working with. And again, the same hypothesis, same steps we had before that we're going to go through. So we're going to be looking at those assumptions. We're going to look at all the different pieces. The assumptions for a student's t-test or a one sample t-test is you're going to have a random sample. Again, you're always going to have a random sample. Hopefully that's what you took. And that's where you're just going to describe how did you actually collect the data? What did you do to get those data? Again, it could be stated in the problem that they did a random sample. And then the other assumption is the population of the random variable is actually normally distributed. So that's where we spent time on those sampling distributions. We're kind of using the central limit theorem here. We're kind of using the idea that in order to use the central limit theorem, we need to have the variable has to be normally distributed in order to say that the sample mean is normally distributed. And that fits into this whole concept of the student's t-distribution. If we have a large sample, then the test is pretty robust to not having this true. So even if you don't have a normal distribution for your variable, it's probably okay if you have a large enough sample. And 30 is still kind of the rule, though usually we go a lot bigger than 30 sometimes. But it usually what I'll say is I don't have a normal distribution, but I took a large enough sample, so I'm okay. And so we would go through the same assumptions, the same assessments we did from chapter 6. And so this is kind of how this works. And I just want you to know what the student's t-distribution is in order for us to actually do, talk about things that we're gonna do next time. So this is kind of where we are of what we're doing. We have our one sample proportion test. We have our one sample t-test. Again, we're not actually doing any of the calculations for this right now. I'm not gonna make you do any, we're gonna do them when we get to chapter 9. What we're gonna do next time is talk about what we call confidence intervals. Hypothesis tests are where we're making decisions about a parameter from data. A confidence interval is we're actually estimating it. So to go back to the example we did today, we're saying now, hey, there is evidence to say that the proportion of voters voting in the 2020 election is more than 55.7%. Well, the question comes up, well, what is it? And that's what the confidence interval answers for you. The confidence interval actually tells you what is that proportion? What is an estimate for what that proportion is? And so that's what we're going to spend time next time talking about is how do we do confidence intervals? What do they look like? And how do we calculate them? I'm going to get into that next time. I know we actually have like 15 minutes left of class, but I don't really want to spend any more time doing stuff today. This is such an unusual situation of how we're doing classes now that I don't really want to spend a lot of time overloading your brains if I can help it. You've got a lot of things going on in your minds right now. So what I'd like to do is I'd like to actually have us be done for the day. Next time we will do confidence intervals, look at what the general idea of a confidence interval is, how does it work. We may get to an example of calculations, we may not. We'll see once we understand how it works first. And then we'll get into the calculations also of how those work at another time. And then I'm gonna get into 2 sample. So I wanna give you kind of an overview of the way the class is gonna go from here on out. And I'm gonna stop sharing and I'm gonna turn off my